right, so ladies and gentlemen, I want to take this opportunity once again to welcome all of you here. We are going to do a practical version of the R, a very practical version. And as always, we are still continuing using this. You might remember that it was this same data that I used, and I called it Brukutu coded, if you can remember. Okay, we called it Brukutu coded. And this was the Brukutu coded data. In fact, you can see it a bit here. The last time we met, we generated a descriptive statistics for this data on the coded data. We also generated a correlation matrix. In fact, if you check here, this was the descriptive statistics that you see. Correlation matrix, it was so fast. We did it so fast. In fact, if I were to do it so fast again, all I would have to do is to just click on data tab here. All I have to do is to just click on data and click on data tab. And I just have to choose correlation in the list. And once you choose correlation, you will highlight all the information that you have in the data. And once you highlight everything like this to the end, okay, you can now select the labels in first row, choose where you want the output to be. This we have already done, so I'm not showing it. And then you now select where you want the results to be. Let's say I want the results to be in this cell, J17. I click OK, and boom, a beautiful correlation matrix is showing here. Okay, so this was what we did. And once you have that, you now go to Home and click on General and select number, and everything will turn to 2 decimal places. We did this. Do you remember? If you remember, just type Y for yes. That's what we did. Okay. Then we also generated the regression by going through the same process. Okay. So going through the same data tab on the far right, we clicked on the, and then we generated this beautiful, we clicked on regression. Okay. When you double click regression, the thing about regression is that regression will require that you put in the dependent variable. So inside the input range, you select the dependent variable. But what is a dependent variable? It is kill. That's a dependent variable. So you come and select kill and drag it all the way to the bottom. Okay. And then you go to the input X range. What is the input X range? Those are all the independent variables. And it starts from P all the way to M. So click P, drag it all the way to M, and drag both down to the end of the data set. Once you're done, you click labels in first row, choose the output range. Okay, choose the output range, and then you click the space where you want the results to be. I want to just select cell J28. And once you click OK, a beautiful regression result is displayed here. Because the regression results are all in decimals. So what we did is that we went to Home tab, we selected General, changed General to number, and we were able to put everything in 2 decimal places, as you can see. So this is what we did with the coded data. What we are going to do now is with the uncoded data. So we are going to take this data set and we are going to take it to R. So what you want to do is that I want you to go to your sheet or Brukutu for R or Brukutu R, the one that has the same information that you are having in this Excel. Just highlight the entire data set. If you click anywhere in the data set and do Control A, it will highlight everything. If you do Control C, it will copy everything. And once you do that, you'll let me know. Mary has a question. Okay, so Mary, you have a question. So I think what you can do is you can click on mute and then ask a question.
So please, the data I have is not categorical. It doesn't have a categorical disinformation. All is numbers.
I have here.
Pardon?
It doesn't have what I have here.
Yes, mine is just numbers.
When you say yes, it means it has.
It doesn't have.
Okay. So when you look at the sheet, you see that there are two sheets. Are there two sheets? You know what I mean by sheets?
Yes, the spreadsheet. The
Yeah.
Excel spreadsheet.
At the bottom of the each sheet, there's a name for the sheet. At the very bottom of the Excel, there's a name. Brukutu coded. Do you have Brukutu coded?
Yes, that one I have.
What else do you have apart from that?
That's the only one I have.
And you took the data from who?
From the platform.
No, I don't think that's the only one you have then, because everybody else will have two sheets. So you may either mistakenly deleted this very one you have on the screen. Okay. So find a way, go back to the page and then download the new one, because all the data will have two sheets. Okay.
Okay, sir.
All right. So, ladies and gentlemen, for those of you who are following me, what I want you to do is to highlight the data and copy the data. When you copy, don't go and paste it anywhere. Once you have copied, go to your Brukutu for R. Sorry, go to your R Studio. So get to your R Studio. This is my R Studio. And I want you to open your R Studio. Now, you may have some numbers. You may have some information already typed. Okay, or you may not have some information already typed. So follow what I'm doing. Just type gen equal to read dot delane bracket, then you bring double apostrophe clipboard. This command, we already know it. I told you to type it. So once you've typed this command, while the cursor is blinking on that same horizontal line, click run at the top. Click run here at the top. And with the data already copied, click run. And when you click run and you come down to the console down here, you will see that the name of the data you typed has been written in blue. That means the data has been loaded. That means the data has been loaded. Those of you who have already typed all of these commands, once you've done the copy, you come here, just run. Click on the name and run. Once you do that, in order to see that the data has been loaded, there are two ways. I'll give you the easier way. Just type the name of the data again. We called it gen, so just call it gen as well. And then run it as well. Click run. After typing gen, click run or click Control Enter. And when you do that, the entire names of the data will show down here, just as it was. Please listen. If you have your data, the headings, they should be, the occupation should be OCC instead of OCCU. So if you have OCCU, please go back to the Excel and go and rename it. If you have OCCU, go back to the Excel. If your Excel has OCCU, like that. If your Excel has OCCU, remove the U and then save it and then recopy the data and take it to R and then run it. Remove it, ensure that it is OCC. Copy the data, take it back to R Studio and then run it. Okay. So those of you who have the command, I hope you are clear. If you are not clear, you can raise your hand and I'll address possible challenges. Okay. So now our data is inside the memory of R. That is our data. Inside the memory of R. The question now is, how do we work on this data? How do we work on it? Victoria, you can unmute yourself and ask a question.
Sir, please, I'm not clear. I'm able to highlight my data, copied it, but to paste it at the R
Don't
Studio.
paste. You remember I said you don't paste, so you don't use paste. I told you that when you come to the R, you type the command I typed.
Yes,
Once
I have it here.
Command, then you click
Yeah.
run. I
click what?
Run at the top. Run at the top. R-U-N, running, run. If you can't see run, just whilst your cursor is blinking at what you have typed, is the cursor blinking on that line?
Yes, please.
Click Control down and click enter.
Okay.
Hold the control key and click enter. That will run the data. So you should now see the data down. You should now see the same write-up in blue down there in the console.
Right, sir.
Huh?
Okay, I'm okay. Thank you.
All right. Okay. All right. So it's okay. So what I want us to do now is, now that the data is in the memory of R, and like I said, this is a very important question. You know, it's a compulsory thing. So I'm taking my time so that you can follow me. Now, there were so many other things we dealt with this data. So many. So you have so many of your commands. But because of time, I'm going to deal with the important commands and run them. I'm going to run the important commands first. Once I'm done, I'll come back and come and run the other commands that are not so important. Okay. So the most important command I want us to work on for now is this command. And I'm going to type this command so that you can all see it. The command is known as gen multi. So you type gen multi. For those of you who have typed it already, you will see this. Okay, you type gen multi equal to LM, just as you see it here. Then you write your capital Q. As you know, the capital Q is the dependent variable, which is a quantity demanded of gen bitters. Then you bring this sign, which is a tilde sign. Now, if you don't take care, you might not see where this sign is. But depending on the kind of machine you have, this sign is found after pressing the shift key and pressing that sign called, if you have a very good laptop with a proper symbolisms, the symbol tilde will show at the top. Or for some of you, the symbol that is showing the keyboard you have to press after pressing the shift key in order to have this. That particular keyboard is like it's like that keyboard that goes from left to right and then bends. It's like L. It's like L, which is turned 360 degrees also. It's a very funny keyboard symbol. I don't have it. I don't have it, probably because I have a good laptop. But for some people, they have strange laptops, so they have it. And this is a symbol. Take note, it's a tilde. It's called tilde sign. It's like this kind of, this kind of S turned horizontal. The letter S turned horizontal. That is how it looks like. Anyway, you bring that tilde sign, then the names of the independent variables, P, which is a price of gen bitters, C, which is a complement price of gen, M, which is an average income of the, yes, Adam.
Yeah, Doc, please, it looks like there are spaces between the Q and the approximate sign.
Whether there's a space or not, it'll work.
Okay, thank you.
Okay. So once you have the P plus C plus M plus lock, check it, it is LOC, spellings matter, plus OCC, plus REL, comma, the comma must come, Then data. After data, then you have gin equal to gin. Then the bracket closes. Then a semicolon. After your semicolon, type summary into bracket, bring a left bracket. Once you bring the left bracket, the right bracket will come automatically. Then inside the summary, type the equation you gave. And the equation you gave is a gin multi. So retype gin multiple regression, multi. Okay, and that's it. So this is a command you should have, and run it. If you have this command, just click run. Okay. Who raised a hand? Anyway, just click run, and you will have a beautiful regression result showing down here in the console. So I'm going to click run, and then beautiful. You see it down here. You have some beautiful, beautiful, beautiful regression results showing down here in the console. So many of you have got it. Those of you who have it, raise your hand. Okay. Those of you who have gotten this result, kindly raise your hand and let me see. Okay, so a good number has it. It means that you are following. It means that you are ready. It means that you are prepared. It means that nothing is disturbing you in your background. Please stay relevant for me. Just the next 2 hours is you and I. Okay, I'm about to ask you 11 questions on this regression result. And I'm going to ask you the same 11 questions in the exams. So please pay attention. For each question, I will dictate the question, and then you will write the solution. Sorry, you will work the solutions together. So I will dictate the question, and then you will write it down, and I will solve it together. Okay, so the first question is this. Is the regression model reliable? So the first question is the regression model reliable? Okay. Is a regression model reliable? Is another way of seeing this is that, is a regression model well fitted? Is a regression model well fitted? Is a regression model well fitted? When we say that is a regression model reliable or well fitted, what it means is that you want to know whether all the independent variables are doing their job. Combined together, whether they are doing their job. What is their job? Well, the independent variables, their job is to influence the dependent variable. Each predictor is supposed to cause, influence, okay, predict the behavior of the regressant. Each regressor is supposed to predict the behavior of a regressant. Now, what you are going to do is this. What you are going to do is you're going to find out whether the regression model is reliable. There is a value you have to use, and the value you use is known as the R squared. The R squared. The R squared. Now, in your table, you will see that they did not call it R squared. Who can type or raise a hand and tell me the name that the table called it in your R studio? Okay. They did not fully call it R squared. Let me just take you to the results. In your results, they did not call it R squared. They called it by a different name. What name did they call it? Carrie, what name did they call it?
Adjusted R square.
Okay, that was the brother of R squared, but they didn't, that is not the one that we're looking for actually. So what is the other one? It's not that one, it is this multiple R squared. So you see it here, okay. Not adjusted, but the multiple R squared. Now the adjusted is the one following the multiple, okay, but this is they call it multiple R squared. The multiple R squared is the same as the R squared. It's the same as the R squared. And that is the name That is what you use to determine the regression model, whether it is well fit. Okay, so we are going to do that. But how would you know that the regression model is well fit? Well, ladies and gentlemen, to determine whether the regression model is well fit, here is a rule. Okay, I'm giving you my sustained rule, and according to Helen Black, if the R square is greater than or equal to 50%, if the value of the R square is greater than or equal to 50%, then the regression model is well fitted. Then the regression model is reliable. Okay, so if the R square is greater than or equal to 50%, then the regression model is reliable. Okay, you can rely on it, you can depend on it. But first, let's understand what the R square means. What is the meaning of the R square? Well, I can tell you that the R square measures the variation. Everything I'm saying, you want to write it down. Okay. The R square measures the variability. If you are taking notes, that's why I'm slowing down. The R square measures the variation in the dependent variable, okay, explained by all the independent variables. That is R square. It measures the variation in the dependent variable explained by all the independent variables. It measures the variation in the dependent variable explained by all the independent variables. So what is the R square doing? The R square is a measure. It's in percentage. It's a measure. It's in percentage. In fact, all the time use 2 decimal places when you are rounding up things. So it's a percentage. And it tells you that collectively speaking, these independent variables are explaining maybe 20% or 90% or 70% of the entire regression model. So let's go and check our R square. Okay. Let's go and check. What was the value of R square in percentage terms? Who can type it there? What is the value of the R square in percentage terms? Type your answer for me. What is the value of the R square in percentage terms? Okay. I said convert it to 2%, 2 decimal place, before you give it a percentage. So the answers most of you are writing is not an acceptable answer. You have to convert the decimals. Mark, your answer is wrong. You have to convert the decimals to 2 before you now multiply it in percentage. So the answer is supposed to be 99%. It's very important you follow this approach. 99%. Very good. I think most of you are getting it now. So now, based on the rule, would you say that the regression model is well fit? Who can raise a hand and tell me and give me reasons? Is a regression model now well fit, and why? Is a regression model well fit, and why? Let me go to Charity. Charity.
Yes, Doc. Doc.
Go ahead.
Yeah, yes, please. Because 99% is more than 50% of the entire work, so it's well fit.
Good. How will you explain that 99%? What does that mean?
How will I explain?
Yeah, what does a 99% mean?
So it means 99% of it. How will I explain, Clara? Is qualified. So meaning there is 1% of should I say error or something?
I like the way you smiled. Okay. So now you've reached a point of no return. So the smiling is the best way to wrap it up. Who can interpret? Because your capacity to interpret that result is significant. You got to be able to interpret the results. Cephas, will you be able to help them?
No, let me try. I would say 99% of the variation in the dependent variable is explained by all the independent variables.
Okay, so now since we know their values, we know what the dependent variable is. You have to mention the actual name of the dependent variable for the thing to be more practical. So how will you do that?
So I'll say 99% of the variation in Q
No,
is
don't
explained.
mention the full name so that it looks practical.
99% of the variation in, I'm looking for the,
You have forgotten what Q stands for.
yes, boss.
Is a quantity demanded of gene bitters.
So 99% of the variation in the quantity demanded of gene bitters is explained by the location.
No, this time you don't have to mention all of them because that will take time. You can use your
Okay.
by all the independent variables. Okay, that's it. Well done. So 99% of the variability in the quantity demanded of gene bitters is explained by all the independent variables. Guys, you need to know how to interpret the R-square statistic. You need to be able to know it. You'll be asked the same thing. You need to know. And you must have the letters in your mind. So the preamble must always be in your mind. Of course, you get a preamble first. Okay. All right. So someone is asking that where did we get the value of the R-square? All right, let me show you where we got the value of the R-square. So when you go to the R studio, okay, inside this R studio, look at the very bottom. Okay, I've highlighted something here. Mary, you can see the word multiple R squared. That is a R square. And when you look at the number, it's 0.9984, which when you round it to 2 decimals, it is 0.99, which when you multiply by 100, it becomes 99%. So that is why we said 99% of the variation in the dependent variable is explained by all the independent. In this case, the dependent variable is a quantity demanded of gene bitters. Okay, that's it. R squared, done. Let's go to the next question. The next question is, this. Please put this on. Are the coefficients jointly significant? Please, I will encourage you to pay attention, okay? It's very important because when you don't pay attention, you'll be stuck at some point in time. Okay. So pay attention. So the question is, are the coefficients jointly significant? Are the coefficients jointly significant? Are the coefficients jointly significant? So that's the question. That's the question in hand. Now, what does that mean? What does that mean? Now, if you have not written the question, write it well. Are the coefficients jointly significant? So this question is looking at joint significance. Okay. Joint significance. The word joint deals with collectivity. Okay. So what does that mean? Well, it's similar to the R square, and this is measured by something known as the, so I'll come back to that. But let's look at the word. R square looks at how all the independent variables in percentage terms are influencing the dependent variable. In percentage terms, how the variability in the quantity demanded of gene bitters is 99% explained by the combined variability. But it doesn't tell us whether that is significant or insignificant. The F-test, sometimes I call it the p-value of the F-test, the p-value of the F statistic that will tell you whether the coefficients are jointly statistically significant. That will tell you whether the coefficients are jointly, collectively. You see, a particular coefficient may be significant, another coefficient may not be significant, but when you put all of them together, are they jointly significant? The p-value of the S statistic will tell you that. So that means that you need to go to the table and identify the p-value of the F statistic. Now look at it here. At the very bottom of the regression result, and I'll give you the regression result just like you have it here. The very bottom of the regression result, you will see F statistic is 329.1 on 8 degrees of freedom and 31 degrees of freedom. And you have been told that the p-value is less than 2.2 E minus 16. 2.2 E minus 16. What does that mean? Let's find out what that value means in the first place. 2.2 E minus 16. What is that? What is that? That sounds like Hebrew. Well, no, that number is something. Let me give you 2.2 E minus 16. Let me write a different one. 4.48 E minus 5. 5.5 E plus 6. 7.728 E plus 2. Okay. So I'm giving you multiples of this. So what does 2.2 E minus 16, what does that mean? What this means is that there are 16 zeros before the 2.2. Or let's put it this way, there are 16 zeros before the 2.2. So what this means is that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros before 2.2. That is what it means. And after you've written the 16 zeros, then you bring a point right after the first zero. That is what it means. So it means that there are 16 zeros before 2.2. And when you look at this number I've just written, it simply means that it's approximately one number. Approximately one number is that? Zero. Exactly. Zero. Okay. So this means that the p-value for the F statistic is 0. Now, what if you have 4.48 E minus 5? Once again, it means that there are 5 zeros. 1, 2, 3, 4, 5. There are 5 zeros before 4, 4, 8. And then after the first zero, you bring a point. So this means that there are 5 zeros like this, or after the point, 4 zeros, before 4, 4, 8. So each time you see some numbers and you see E minus something in front of it, that is what it means. Now, what if the number is not minus, but is plus? Well, like you have here 5.5, blah, 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 blah. Okay. What does that mean? Who can tell me? Who can get me a clue of what that number means? Because your capacity to tell me what that number is will indicate that you are following me. Who can tell me what that means? Okay, let me see. I like participants. I like participants. Agnes, teach them for me.
Good evening, Doc. So 5.5 E plus 6 means we would have 6 zeros after 5.5, meaning we'll have 5, 5, 0, 0, 0, 0, 0, 0. So that will be 55. Should I call it million? Yes, 55 million.
Good, got it. Let me see whether somebody wrote another answer. Okay, so somebody said there are 5 zeros after the figure 55. Someone says there are 6 zeros. after the figure 5.5. Okay. And that is very important. I like the one who is writing the answer being given, oops, by the guy. Oh, why is my computer frozen? Hold on. Computer is frozen. I don't know why. Oh. Okay. All right. I hope you guys can see me. So you have 6 zeros after 55. 6 zeros after 55. Some of you are writing things that you really don't know. Somebody is adding points to every number that he sees. Every number is adding point to all of them. I don't know where the person is coming from, but the person is adding points to every single number there. So my computer is okay. I need to close some few things, please, just a second. All right, so when you have something like 5.5 E plus 6, did I write plus 6? I think I've closed that thing. Okay, did I write plus 6? Yes. E plus 6, was it plus 6?
Yes, plus 6.
Okay, good. So 5.5 E plus 6. Okay, so what it means is that you are going to have 55 and then you have 6 zeros, which is the same as 4.5, sorry, which is the same as 5.5 million. Okay, it's the same as 5.5 million. So you have 5.5 times 10 to the power 6. That is simply what it means. 5.5 times 10. I've forgotten the number that I wrote. So if it is 5.5, that's it. 5.5 times 10 raised to the power 6. Yes, Kwame.
So we don't take notice of the 5.5, the 0.5. We just add the zeros to it.
Yes.
So I think so this one is 5.5. So we just add the 6 zeros to the 5.5. I just want to know, take away. I don't understand that. Thank you.
You don't understand what? I didn't hear you. Okay. Don't just look at them again. I mean, this one is very simple. Like I said, 5.5 times 10 raised to the power. So because you are doing times 10 raised to the power 6, okay, you can now, remove the point or add it, depending on which angle you are looking at it. But if you don't do the 0.5, of course, but when you want to do 10 raised to the power 6 times 5.5, you will get that. Okay. I want to close this one so that I can get back to where, and then I think I can get back my screen. I want to be sure that my R Studio is showing here. Okay, Sakite, you have a question. Mark, you have a question.
Yeah, hello, sir. So does it mean that after running it, the zeros, you have 5 zeros after the second 5? So that instead of having 5 billion, now you have 5.5 million.
Are you asking?
Yes, please.
Please ask again. Sorry, ask your question again.
The e to the power of 6, there are 6 zeros, but then the rounding off of the zeros will start from where the point is. So you have the first 0 moving it to.
If you have 5.5.
Yes, please.
If you have 5.5, E minus 6. Is it minus 6 or plus 6? Which one did I do?
What you are doing now is plus 6.
Okay. So if you have plus 6, it is 5.5 times 10 to the power 6.
Yes, so in effect, it means you have 55 and then 5 zeros and not 6 zeros.
Well, if you do that and you get that, you use a calculator and get that. And then tell that's what you get, right?
Yes, please.
Okay. So if you do 5.5 times 10 raised to the power 6, if that's what you get, that's fine.
Okay.
I've not checked that.
Okay. Thank you, sir.
I saw another hand. Let me see. Was it Mike Sakiti? Yes. Sakiti.
Yes, Doc. Okay, so I'm thinking then if whether you see it as negative or positive, you still have to use the formula as let's say 10 raised to the power which number it is. So for example, the first one you gave, so it's going to be the 2.2 times 10 raised to the power negative 16. And if it's also positive, it's going to be the 5.5 times 10 raised to the power 6. So I just want to confirm if you can use that formula to also get such answer.
Absolutely, you can.
Okay, thank you.
All right, okay. So now let's go to the, how do you know? I don't know where I was, but I want to believe that I was on the F test. How do you know that the coefficients are jointly significant? Let me just use a new page because I'm not seeing it. So the question was joint significance. Joint significance. How do you know that the coefficients are jointly significant? Well, here is a rule. If the p-value of the F statistic is less than or equal to 0.05, if the p-value of the F statistic is less than 0.05, then the coefficients are jointly significant. That's what it means. Then all the coefficients, not one of them, not two of them, all of the coefficients are collectively or are jointly significant. Okay. They are jointly, collectively significant. So I wanted to note this. So as long as the p-value of the F statistic is less than 5%. Now let's go back to our results, and you can see that it was E minus 16 and E minus 62.2 E minus 16 means it's approximately 0. So it simply means that all the coefficients are jointly significant. Finish. Let's look at the next question, unless you have a question. Okay. Other than that, let's go to the next question. The next question is, which independent variable is statistically significant? Which independent variable is statistically significant? Which independent variable is statistically significant? Then, gentlemen, I want you to look at all the independent variables. Okay? All of them. Look at them. These are the independent variables here. These are the independent variables. And these are their coefficients. Their coefficients in the regression model is known as estimate. Okay, so the coefficients are the same as the estimate. And at the far right, you will have the p-values. You will have the p-values. Okay. Now, if you want to know whether a particular coefficient is statistically significant, all you got to do is remember that the intercept is not a coefficient. So I just want you to know that. The intercept is not a coefficient, so that one is out. So the first coefficient is P. If you want to know whether P is statistically significant, all you got to do is to check the p-value, just like we did for the F test. Okay? The same thing here. If, and I just want to write that, if the p-value of that coefficient is less than or equal to 5%, then it is significant. If the p-value of that independent variable coefficient, if the p-value is less than 5%, if it is less than, strictly 5% or equal to 5%, then it is statistically significant. Now, remember that I've told you that you should round it all to 2 decimals. Everything rounded to 2 decimals. Okay, this is just my standard I'm giving you. Round it to 2 decimals. So look at the price and look at the p-value of the price. If you look at the p-value of the price, if you round it to 2 decimals, what value is that? If you round the p-value, this p-value, okay, if you round it to 2 decimals, what do you get? You get what? I need to be sure that you are typing the correct. You get 0.05, correct? Now, on the basis of that, can you say it is significant or is not significant? Type it in. Is it significant or insignificant? Is it significant or insignificant? It is significant. Well done. Well done. I think Eleanor got me right. It is significant. The reason why it's significant is because the value is exactly 5%. The value is exactly. If we were not using 2 decimals, we would have said it's not significant because it would have been 5.3%. Okay. But because we are saying that everything should be 2 decimals, that will make it 5% on the dot. Okay, let's move on. This one is very quick. Let's look at the other independent variables. Your job is to tell me whether the rest are significant or insignificant. So look at the next variable, complement price. Complement price, is it significant or it is insignificant? Complement price, okay. Is it significant or insignificant? Is it significant or insignificant? Type your answer for me. Significant S, insignificant I. Is it significant or insignificant? It is significant. Very good. Well done. And the reason is because the p-value here is 1%, which is less than 5%. Now, income, is it significant or insignificant? Is it significant or insignificant? Income, it is insignificant. Very good. Now, location urban, is it significant or insignificant? Location urban, significant or insignificant? It is insignificant. Very good. It's insignificant. Now, occupation teaching, is it significant or insignificant? Occupation teaching, significant or insignificant? It is significant. It is significant. Very good. Occupation trading, is this significant or insignificant? It is significant. Very good. Occupation trading is significant. Religion Christian, if you look at the value, you can see that it is 1.16 E minus 5. So that is approximately 0. Significant or insignificant? It is significant. The last one, significant or insignificant? It is significant. Very good. Now, if you have a mathematical eye, you will notice that all those with stars are significant. All those with stars and dots, okay, depending on whether you are doing it at 5% or 10%. The stars will tell you at what level of significance. So when you look at the significant code, see, you don't have to even check the last 4, because the fact that they have 3 stars means that they are significant at 0.1%. That is what it means. That is this one. They are significant at 0.1%. And that is what this is telling you here. They are significant at 0.1%, 3 stars. So that is how you determine significance. So in your work, you'll be asked whether one by one, in fact, you'll be told that which ones are significant and which ones are insignificant. You can be asked, identify all those that are significant. That's it. And you should be able to tell. The key point is understanding the significance. Who is not clear? Okay. Somebody is not clear. Let me know. Okay, Mark, it seems you have a question.
Yeah, Doc. So when you're asked to state which independent variable is statistically significant, sorry, are you supposed to just list it or give the corresponding p-values to show that it's significant.
Now, if you say a particular independent variable, if the question is which ones are insignificant, okay, you just write that and then write the p-value. So you say that p-value, which is equal to, so let me just show you how to write. I understand your question because you want to know exactly how to document it, isn't it? So let's say you are talking about price. So you say that price is significant. Of course, you write a full sentence. Okay. And then you now bring a comma, a semicolon, and then you write p-value is equal to 0.5, which is less than, sorry, in this case, which is equal to 0.05, which is equal to 0.05. Let's go to the last one, religion Muslim. So you say that religion Muslim is significant. Religion Muslim is significant. Why? Okay, they write p-value is equal to 0, which is less than 5%. That's it. So these are some of the ways, these are the ways you got to write it if you want to know exactly how you write it. Is it clear? If it's not clear, I can explain further. Okay, I'm sure you got it. So that is how you write it. So religion, Christian, significant, okay, because p-value, which is blah, 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 is less than 5%. That is how you got to document it. Okay, so now you know partial significance. You know how to determine the significant value of all of them. Gazari, you have a question?
Oh, good evening, Doc. Doc, so far I've understood everything you said about the significance and insignificance. But when it comes to the p-values of the occupation training, we have 1.08E, which is 0.9. I thought you said when it comes to those things, it means that, oh, okay, it means it's before. Sorry, I've understood. Sorry about that.
So let's go to the next question. Let's go to the next question. The next question is specify the entire regression model. Specify the entire. Okay, hold on. I'll bring that question later. I'll bring that question later because of something. So let's go to the next question. Interpretation. Just write interpretation because you're going to spend some bit of time here. How do you interpret some things? Interpretation. Okay. So interpretation. Let me just document something for you. So we're going to look at interpretation. How do you interpret a particular coefficient? Please, I want you to know that the independent variables you are seeing, some of them are categorical variables. We call them dummy. They are the same thing. Some of them are categorical variables or dummy variables. Others are numerical variables or numbers. Okay. For example, who can tell me all the numerical variables? Okay, let me take you back to the thing. This you should know from the storyline, not now. If you look at the independent variables, price, complement price, average income, location, urban, occupation teaching, occupation training, religion, Christians, religion, Muslim, which ones are numbers, numerical variables? And which ones are the categorical or dummy variables? Remember, a dummy variable has levels in it. So which ones are the numbers? Well, let me see. Which ones are the numbers? Manuel, which ones?
Okay, so the numbers are the PCM.
Good.
The independent numbers numbered PCM. Yeah.
Okay, so that means that all the rest are the dummy variables or the categorical. Okay, so now how you interpret the dummy variables are different from how you interpret the categorical variables. Okay. How you interpret the dummies are different from how you interpret the categorical. So what I'm going to do is I'm going to interpret one numerical variables. Sorry, how you interpret the dummies are different from how you interpret the numerical variables. how you interpret the categorical are different from how you interpret the numerical variables. So I'm going to interpret one of the numerical variables, okay, PCM. Then I will interpret one of the dummy variables, location, urban, occupation, and then religion. Then after that, one of you will try to interpret it. So watch the way I'm going to interpret it, write it down verbatim, exactly how I'm going to interpret, and then think it through. When I finish, I'll explain it. Okay. So let's start with price. I'm showing you. Now, sometimes the temptation is you want to say holding all other factors constant. Well, for this course, I don't want you to hold other factors. I want to mention the factors. Instead of putting it all together, holding all other factors constant. I don't want you to do that. I want you to learn mentioning the factors. If you are writing a journal paper or writing a thesis, you can do that. You can hold other factors. But for here, I want you to tell me all the factors that are given. Okay, so let's start. Write it down, please. Because the only way you can even learn it is writing it down first. The first word that must come is on average. So write this. On average, given the complement price of Jane, average income of the people, location of the shop, occupation and religion of the people, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin decreases the quantity demanded of gin bitters, by 3.15 units. By 3.15 units. Remember, I was interpreting this negative 3.15. That is the coefficient of price. By the way, if you want the question related to this, the question was this. Interpret the coefficient of price. That's a question. Interpret the coefficient of price. If you are learning how to interpret, if you didn't get it, don't worry, I will repeat it. So let me repeat it one more time. On average, given the complement price of gin, average income of the people, location of the shop, occupation and religion of the people, a 1 unit increase in the price of gin. A 1 unit increase in the price of gin decreases the quantity demanded of gin bitters by 3.15 units. By 3.15 units. So ladies and gentlemen, the first thing you should note is that regression is an average methodology. And that is why you start with on average. Okay, on average, because it's an average method. The second thing is, you could see that I started with giving the complement price. I did not start with price. I said giving the complement price. I started with a C. I did not touch a P. I did not say that the P was given. The P was not given because the P is the one I'm going to interpret. So I cannot hold it constant. I cannot assume that it is given. So price is not given. So you start with everything else is given except the one you are interpreting. That is why I said I started with complement price. Okay, so given the complement price of Jane, given the income, now watch the location. I did not say given location urban. Okay, remember that the other level of urban is rural. So I did not say given location urban or location rural. No, I said given location. Now you look at occupation. There are three kinds of occupation in this story from last time. There was occupation teaching, there was occupation trading, there was occupation fishing, which is not here. So fishing is actually the reference category. Remember, these are all in the storyline from last time. But when I was giving occupation, I did not say giving occupation teaching. No. I did not say giving occupation trading. No. I said giving occupation. I took the umbrella name of the dummy instead of splitting them. The same thing when we went to religion. There are three religions: Christians, Muslims, Buddhists. Now, if you don't see Buddhist here, it's because it's a reference category. And I did not say that giving religion Christians. No, I didn't say that. Giving religion Muslim. No, I didn't say that. All I said is giving religion. So one of the things you should know is that for dummies, you don't pick them one by one. You take the dummy umbrella name and then use that. Then I said a 1 unit increase in the price. Remember, this negative 3.15 is not for the price. It is its impact on the quantity demanded, on the dependent variable. So you cannot say that a 3.15 units in price. No. We always start with the price rising or the dependent variable rising, or depending on if it's not a dummy. We always say it is rising by 1 unit or is falling by 1 unit. Then we look at its effect on the dependent variable. So I said a 1 unit increase, a 1 unit increase, a 1 unit. You see, I use the word unit. I didn't say a 1% increase. I did not say a $1 increase. I did not say a 1 cedi increase. I said a 1 unit. I did not mention the unit of measurement. I did not say dollar. I did not say percentage. I did not say kilogram. I did not say yards. I said unit. Once you keep it at unit, you keep yourself safe. So 1 unit increase in the price, okay, how will it affect the quantity demanded? Then we said it would decrease quantity demanded, okay, by 3.15 units. Units, that's plural, units. So why did I say decrease? Why did I say when it increase will lead to decrease in quantity demand? Why decrease? I'm sure you got that. Because the negative 3, because of the negative in front of the 3.15. So the sign in front of the number you are interpreting, that sign will tell you what is going to happen to the quantity demanded. So I increase price. If the sign was positive, I would have said then that will also increase the quantity demanded. But because it was negative, it should be decrease the quantity demand. So that is how you do it. And you can see that I said 3.15 units. The units are in plural because it is more than 1. Who can interpret the coefficient of income, M? Who can interpret the coefficient of income, which is M? the coefficient of income? Who will be bold to try to interpret the coefficient of income? Let me see. Mark, you want to try?
Yes, Doc.
Mm-hmm.
So on average, given the price of gin, the complement price of gin, the location of the shop, occupation and religion of the people, a 1 unit increase in the income will result in decreases the quantity demanded of gin bitters by 0.98.
Mark, you tried, but you missed something. Okay, I thought you had finished. You missed one word, 0.98 units.
Yes, unit.
So that word must count, units. But apart from that, everything was fine. Everything was excellent. So ladies and gentlemen, if you are sitting and watching me, okay, now you can see that somebody has cracked it. He said on average, that was a key important word. This is 7 marks. This interpretation is 7 marks. So you want to really pay attention and learn it joyfully. Okay. So he said on average, given the price and complement price of gin. So you see, this time he went and then included price because he's not interpreting price. So he said, given the price and complement price of gin. Then he went on to talk about what? Location of the shop. He jumped income because income is what we are interpreting. So he jumped income. So he said, location of the shop, occupation and religion of the people. Then he says, why you need to increase in income? Decreases. Why decreases? Because of the negative. Decreases the quantity demanded of gin bitters by 0.98 units. That is how you do the interpretation. So you're going to learn, you want to master how to interpret dynamic variables, changing variables, variables that are not static. They are changing. You see, price is always changing. It's not like a dummy. At least dummy variables don't change easily within a year. So let's go and interpret one of the dummy variables. And I'm going to do, for the last one, religion Muslim. I'm going to interpret the dummy called real Muslim, religion Muslims. Are you ready? Let's write. On average, and you will notice that this is very, very different from the numerical interpretations. On average, given the price and complement price of gin, on average, given the price and complement price of gin, income of the people, that's M. Location of the shop, location of the shop. So this means that you have to know the storyline. You have to know the story. You have to know that the location is for the shop, it's not of the people. So you don't say location of the people, no. Location of the shop. And occupation of the people. And occupation of the people. You can see that I did not talk about and religion of the people. And occupation of the people, comma. Quantity demanded is predicted or expected to be. Quantity demanded is predicted or expected to be. And this time I'm going to write it so that you see. It's predicted or expected to be 23.01 units less. 23.01 units less. If the people are Muslims, if the people are Muslims than Buddhists, if the people are Muslims than Buddhists, how is spelled Buddhist? If the people are Muslims than Buddhists. So watch the way I interpreted it. On average, given blah, 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 I did not say that I want 1 unit increase in Muslims. No, because Muslim is a dummy. It doesn't increase and fall, at least within a year. So it is a dummy. Dummy is a static variable. Static means it's statute. It comes from the word statute. Statute is like fixed. That is why the word statutory is fixed, you know, it's law. Anyway, that was just English. So after, on average, given PCM, location and occupation, you said quantity demanded is predicted or expected to be. So now the focus is on the quantity demanded. It is predicted to be, it is, or expected to be, not that it's rising, it's predicted to be 23.01 unit less. Why less? Why less? Why not more? It is less because religion has a negative 23 coefficient. The coefficient is negative. So you can't say more. If we were interpreting Christians, we would have said more because the sign is positive. So quantity demanded is 23.01 units less if the people are Muslims. Now you see, I'm now interpreting the Muslims. So I'm saying if the people are Muslims, then the reference category. So before you interpret this, you must have already known what is the reference category for this particular dummy that I'm interpreting. This particular dummy level, okay, that I'm interpreting. What is its reference category? You remember that there were 3 religions and Buddhist was not brought here, and therefore Buddhist is the reference category. Okay, there were 3 occupations, okay, but fishing was not brought. So you must know the reference category in your mind way ahead of time before you start the interpretation. Hope you guys are following. If you're not clear, let me know. That is how you interpret a dummy. And if it is positive, it's more. If it is negative, it's less. Very crucial. Yes, Gazari.
Okay, so Doc, in comparison, you only compare it to the reference category. You leave the Christian out since that one is stated over there. Is that what you mean, please?
Perfect.
Okay, thank you very much.
And what it means is that when you also get to the Christians, you compare that Christian one with the reference category, which is Buddhist.
Buddhist, oh, okay. Thank you very much, Doc.
Now, you have learned how to interpret. If I were to ask you to interpret religion Christian, I'm sure many of you will be able to crack that code. Come on, you will do it. If you were to interpret Christians, all you have to do is to go through the same thing. You don't mention the religion. So you say that giving, on average, giving PCM, location, and occupation, quantity demanded is predicted to be 15.55 units more if the people are Christians than Buddhists. That's it. 15.55 units more. More because the coefficient 15 is positive. You got that? If you are interpreting trading, this time you say that on average, giving PCM, location of the shop, and religion. So you would jump the occupation and then say and religion. Then you now say that quantity demanded is predicted to be 46.47 units less if the people are traders. If the people are traders than fishers. Why fishes? Because fishing was the reference category. If the people are traders than fishers, then the quantity demanded will be 46 units, 46.47 units less. Guys, please know this. Note that if the quantity demanded will be 46.47 units less if the people are traders than fishers, then it means that it will be 46.47 units more if the people are fishers than traders. I just wanted to know that it's the opposite. If you are speaking for traders, it will be 46.47 units less. If you are speaking for fishers, it will be 46.467 units more. It's just the opposite. But of course, we always want to speak for the one that is here. Okay, very good. Now, we have done interpretation, and the next thing we want to consider, let me see if Venice is here. The next thing that we want to consider now has to do with, let's go to the next one. You write this down, because there's one particular one that we need to address. Okay, so write this, specify the entire regression model. Specify the entire regression model. That's the next question. Specify the entire regression model. Now, ladies and gentlemen, the entire regression model is specified when you are bringing the beta parameters. You remember the beta naught, the beta 1, the beta 2, that is how we specify the entire regression model. So I'm going to do that with you. How do you specify the entire regression model? Now, you specify the entire regression model using the information that you have right here on the section on the far left here. You don't have to conjure any word. Whatever letter or word or words or phrases or anything that is there, just as it is, verbatim, that is the letter, the word that you're going to use. So if it is P here, you don't write price, it is P that you write. If it is location urban, you don't write L because it is location urban. So the word that is there, that is what you're going to use. Okay, so how do you formulate the model? How do you specify the model? Well, given this whole R software, R outputs, all you got to do is to bring the dependent variable first. So you write kill. We know that the dependent variable is kill, so you write kill first. Then you bring your equal to sign. And if you can remember, we always bring the beta naught first. We are specifying the model. This is a very important question. It's 8 marks, so you want to pay close attention to it. So you write your beta naught, then you bring 1, the plus, then you write your beta 1, then you come and look at the first independent variable. Remember, the intercept is the beta 1, beta naught. So that one is already documented. The first independent variable is P. So you write P. Then do plus beta 2. Come and look at the next independent variable, and that is C. So you do C. Then plus beta 3. The next independent variable is M. So you write M. The next one is plus beta 4. The next independent variable is log urban. So you just write this as it is. Log urban. Log urban. Okay. The next independent variable is beta plus beta 5. Then you write your occ teaching, just as it is, occupation teaching, occ teaching, occ teaching. Then you bring plus beta 6. If you know what you're doing, you can now move faster. Okay, occ trading. Then you do occ trading. You see, I could just tell you that you can go and continue, but I'm writing it for you because I just want you to know how important it is to learn how to write these things. Then plus beta 7. I know somebody will be saying, this is too much. Yeah, it got to be beautifully too much. Okay. Beta 7, real Christians. So you just write it, real Christians. Real Christians. Just as it is there. Then you do plus beta 8. My space is finishing. Real Muslims. Then you do plus UI, that is error 10, or U. Anyone of them is fine. Without the error 10, everything is wrong. It is important, critically important, that you bring the error 10 when you are specifying the entire regression model. It is important. Okay, so please take note. Take note, I beg you, take note of that. And please don't go and do ... because you should write religion Muslim. You should write the full word, religion Muslim. Everything must be fully written. This is 8 months. This is a regression model. So it doesn't matter whether I give you a different thing, where here you have W, you have rice, you have cucumber, you have anything. Whatever is here, you are taking them one by one and adding the beta 1, the beta 2, the beta 3, the beta 4, the beta 5. We've learned this already. You write all of this and then you can execute your beautiful. Ladies and gentlemen, is that not beautiful? Is that not beautiful? Okay. So if you have a question, you can raise your hand. I can address it. I think, Gazari, you got a question again.
Okay, Doc, please, with the model we've used so far, I've realized that we're making comparison between some variable that has to do with quantity demanded and maybe the price, and looking at it in the economic terms. So I want to ask, in the regression model, is it always going to be about quantity demanded and price, or sometimes it can change to other situations altogether where we have to compare other variables other than maybe quantity demanded and maybe price and those kind of variables, please?
If you remember, there are some, if you've checked past questions, sometimes we take something like blood pressure. We have taken things like the price of cars. We have taken things like the students in a hostel. We have taken, there are several things that you can do. You can look at the impact of certain things on the salaries of some workers. You can look at impact of several factors on the economy of a country. Okay. So you can look at the impact of consumption, of investment, of government spending, of net export, of days, all on the GDP of a country. So it's not always on quantity demanded. It could be several factors.
Okay, Doc, so if that's the case, with the interpretations we gave earlier, we had to, for example, if we are looking at it in terms of economic terms, maybe indeed, when you look at on an average, we compared the complement price to the average of the income, which we know that in economic terms, sometimes when those two variables meet, the increase in one might deal with the decrease of the of another variable. So in this, if we are talking about it in terms of other, we are interpreting it in terms of other variables. How are we supposed to comprehend that? Is there a way you can help, or we just have to just learn what you just given us, just like that?
To be honest with you, when it comes to writing your thesis and your research, this is just a small portion of what we are doing. If we come to real life, you'll be surprised to know that some of the variables here may not have to be included here. There are other variables that we have to bring. Now, there will be other variables that you are supposed to bring, but you cannot bring. You will see that you have to correct for all mistakes. You have to consider that by the time there is an increase in price, there is already a moderating variable, an interacting variable, and several other variables. Okay, so you're going to see that there are so many conflicting situations, complexities in real life. But what I'm doing is I'm making it a bit simple for you to just have the basic knowledge. So that is why you quite remember, I did say that when it comes to the time when you are going to do your thesis, I will teach you proper research on, well, this is also proper, but this is a fundamental. So we will take your data, we will model your data, specify your data, and we'll get all the other corrections. We will check for heteroscedasticity. We will check for autocorrelations. We will check for normality. We will check for linearity. We will check for residuals. Okay, we will look out for all the possible outliers and all the wrongs and correct them before we move. Do you get it?
Yes, please.
But if we have to do all of that within this short period of the semester, we will not complete it. Okay, all right. So now,
thank you very much.
Specified model. What that's a specified model that we have been talking about. The next thing now, if you don't understand how I specify the model, please quickly let me know, because we are going to use this model to do other things. We're going to use this model to use other things. Yes, Victoria.
Yes, sir, please. I had a network problem at the last end. The real Muslims, and I'm saying plus U. I don't get that one, please.
The plus UI is an error term. If you can remember last time, we looked at the regression model. We said that every regression, specified regression model has an error term. Error term. And then if you check my last video, you see this. So please, if you haven't watched that, go watch. You see that every regression model, the last thing there is the error term. Sometimes we use U. Sometimes, you know, some books will not use U. They'll use epsilon. Okay, they'll use epsilon instead of U. Okay, they'll use something like epsilon. Some people will use like E. All of them refer to the error term, the stochastic noise, the random noise, the idiosyncratic error. You remember last time we looked for several names for this word. So that is it.
Okay, so depending on what they brought is what you're also going to bring there.
Depending on what?
Depending on what is being stated in the question is what you're also going to use as a last U10.
The last one is constant. It's always like this. It's always one of these.
It's always one of, okay, all right.
Yes.
Okay.
It looks like you got to go watch my video, honestly. Yes. You got to go watch the other video because your question clearly shows that you've not watched and looked at the slides and then consider the other video. Look at that, okay, because this is a build-up of that, and that will help you.
Thank you.
All right. So now, this is a specified model. Let's write the next question. The next question is, write the estimated regression equation. 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 Ladies and gentlemen, if you can remember the last time we met, I told you that there are two differences between the specified model and the estimated regression equation. Who can remind us of the two main differences between the specified model and the estimated regression equation? Because I'm going to use that to answer this question. There are two main differences between the specified regression model and the estimated regression equation. What were they? What were the two main differences? Agnes.
Okay, Doc, so with the specified regression equation, it has the error term and then the Greek symbols, which is the beta 1, beta 2, and the like. But with the estimated, it doesn't have the error term, and then it has numerical coefficients.
Right.
Yeah.
Well done. Even if you look into the book, it's at least you took notes. Right. So that is it. That is how it is. So the specified model has, and I want you to take note, the specified model is what we just did. Okay. So the specified model, that one has error term. And that was the last one that Victoria was asking about, the error term. Also, it has beta coefficients, sorry, beta parameters. It has the beta parameters. But the estimated equation, okay, the estimated equation, okay, that one has no error term, and it has numbers replacing the betas. It has numbers. This question I've always asked people. All right. So with that in mind, we are going to now do the estimated equation. We're going to do that one. Okay. So how do we now write the estimated equation? I want you to note that the estimated equation is written just like the specified. The only thing is that we will not bring the error term. Take note. The last one, we will not bring it. The U, we will not bring it. 2, the beta parameters, the beta 0, the beta 1, you have to take them from the regression result. So let's go to the regression, the R regression output. So when you go to the output of the regression model, this is it. There is a section that is known as estimate. You see that? Estimate. So that column, estimate column, that column is referring to the coefficient. The numbers there are going to replace the betas that we wrote earlier. The numbers there are going to replace the betas. So in writing, you have to, now we're going to write the equation. So to start the write-up of the equation, this is what you do. You write the equation like this. Q, which is a dependent variable, is equal to, if it was the model, we would have written beta 0. But because we are writing the equation, the beta 0 will be replaced by the coefficient. And the beta 0 is the intercept. So you have to write the intercept instead of the beta 0. And the intercept is 280.27. So the first one will be the number 280.27. Remember, whilst you are writing them, you should remember that you will convert it to 2 decimal places. Now listen, don't write plus, because it might be that the next coefficient is minus. As you can see that the next coefficient is minus 3.15. So because of that, you don't have to write plus. Always look at the next coefficient before you go and write. Because it's minus, you have to write minus 3.15. Then which independent variable is that? It is P. So you just write it as it is, P. Don't forget, you have to bring the variable letter. Then the next one, check the symbol. You see that is minus again. Okay, so you bring minus, and then the value, convert it to 2 decimal place. The 2 decimal place will be 0.11. So it's going to be minus 0.11. And which letter is that? That is complement price. So that is C. You attach the C. This is 80 marks as well. Then you look at the next one. The next one is also minus. Okay, so that is minus 0.98. So you write minus 0.98. Which variable is that? M. So you attach the M. Then you check the symbol for the next one. That one is also minus. Which minus? Convert it to 2 decimal place. Minus 5.11. And which variable is that? It's log urban. You don't have to shortcut it. You write it as it is. Log, that is location, urban, just as it is. Then you check the next one. The next one is minus. That is minus 19.43 if you convert it. 19.43. So you do the same thing, minus 19.43. You see, I have to round the 429 to 43. If you don't do that, you lose marks. So it's important you learn the conversion. Anyway, then you attach the name, and the name is OC teaching. So just write it as it is, OC teaching. Then the next number is minus, because it's minus 46. So you do minus 46 point, and when you check it is 47. And which value is that? Which variable? That is a real Christian. So you write it. Oh no, that is OC teaching, OC trading. So occupation trading. So you write OC trading. Okay. You have to take your time. This is why you don't want to get it wrong, because the next question, which is 11 marks, will depend on this. So you got to be correct. So now the next one is plus, because that's for Christians. So you do plus 15.8. 55. And that is religion, Christians. So you write religion, Christians, okay, like that. And then once you do that, you know that you are left with the last one, which is religion, Muslim, and that is minus. So you do minus 23.01 real Muslims. You don't have to bring the error term. We have already said it. This is how you specify the entire regression model. I hope you are writing. Whilst I'm writing, I got a hope, because you see, life does not reward you according to your definitions. Life rewards you according to the quality of your thoughts. Life rewards you according to your definitions. Definitions matter, ladies and gentlemen. So what I'm saying, I'm defining, I'm showing they matter. You want to do the same thing. It's a pattern. This is not difficult. This is a pattern. Follow the pattern. Do as I do. Walk my walk. Dance my dance. Sing my song. And you will by no means fail. By no means. Okay. Who is not clear here so that I can, I'm sure you've gotten the point. You see, by going through each one of them, you've done that, and so it should be fine. This is the regression estimate equation. Once you've done this, we are left with the very, very last but one important question. So let me give you that, and then we'll now come back and come and look at something very important. The interpretations are very, very, the model that we just wrote, they're very, very important. So it's important you learn how to work on this. Okay. So, unfortunately, unfortunately, what I have written here, I hope you have written the same thing, have you? Because I'm going to delete them. I should have written them. I hope you've written them. Please, if you have written them, just type Y, yes, and let me be sure. Because I'm going to wipe this thing and then go to the next one. It's very important you are writing, because writing gives your communication, your mental gymnastics. You are transferring beautiful information from your hypothalamus to your thalamus. Information gathering is powerful. Your memory lanes are working. Okay? Infinitesimal information are being transferred through your cerebellum, Okay, your cerebral cortex is enhanced. Writing gives you power of the brain. Okay, so now let's go to the question, and this one is called prediction. And I want you to note prediction because it's the last most important question. Okay. Before we go to the very last one. Prediction. As for prediction question, I'm just going to show you in the slide. I'm going to show you in the slide. And I'm sure you can see the slide here. If you're looking at the slide, you see that the prediction question, the first one says this. It says that, what is a predicted quantity demanded? So it's like if we know the price, the complement price, the income and other things, then we should be able to predict what the quantity demanded will be. That's the question. And this is practical. You can predict the next level of dollar rate, the CD dollar rate, you can see. You can look at past, previous, other factors and predict the GDP of a country. You can look at past, other factors of a particular company and predict the next price they should charge. You can predict the demand for carpet the next week, the subsequent week, based on the information you have. So let's assume that currently we want to know the quantity demanded, we want to know the actual value of kill. And we have been given certain things. We have been told that the quantity demanded of kill that we are looking for, it has a price of 10 Ghana. Now, this means that everything that you have the equation must be ready. Now, do you remember the equation? The first number of the equation was 280 0.27. That was it, first number. And then the second number of the equation was negative 3.15. Do you remember that? Okay. Negative. So I'm just writing that, negative 3.15. But look at the question. The question says, and now we want to know the actual value of Q that sells for 10 Ghana cedis. What variable is that? Which variable is a 10 Ghana cedis? Type it in. Which variable? That variable is price. Very good. It's price. So the value that, instead of writing the price here, you put in the variable that you have been given. And that variable is 10. So you put 10 there. So it's like every variable, the question will give you, then you will now find the value of the Q. You have been told that this quantity demand that we are looking for, we're predicting, it has a complement price of 50. So go and write the coefficient of complement. Do you remember that coefficient of complement? Well, just look at your own and you'll notice that it is minus 0.11. So complement, normally I would have written 0.11 C. But instead of the C, we have been told that the complement price is what? 50. So you put in 50. The next is income. Okay. And if you can remember, if you check your write-up, you'll notice that income is actually minus 9.98. Okay. So you write minus 0.98, but instead of income, you were given the income. How do we know? Well, you didn't get it straight away. You were told other things. Then watch, towards the end, you were told that where the Christian population on average earn an income of 5 cedis. So you now know that the income M is what? Is 5. So you put in the value 5. Now watch this. If you check carefully, you will notice that the next variable after income is location urban. And if you check the coefficient, it was minus 5.11. So we write minus 5.11 into bracket location urban. But we were told in the story, let's go back. It says that it has a complement price, okay, of 50. It is sold in a efficient rural area. So watch this. It is sold in a efficient rural area. Because it's in a efficient rural area, it means that it's not what? Urban. So our value for urban is a dummy. Will it be 0 or 1? Because these guys are in a rural area. But what we have here was location urban. So what value will it be? Will it be 0 or 1? It will be 0. Because so it means that the value for urban cannot have rural value, because what we have here is what is there. The fact that is there is present means it's 1. It's not present means it's 0. And so there's nothing for location urban. So location urban here will be 0. That is how dummies are recorded. They are recorded as 0 or 1. Then you go to your next number. The next number, if you check yours, you'll notice that. And you notice that that one is 19.43. Okay. So you do minus 19.43. And which one is that? That is occupation teaching. Occupation teaching. You were told here that these people are in efficient rural. You see, you always go back to the question. They are in efficient rural area. So occupation teaching will be what value? That one will also be what? 0, isn't it? Occupation teaching will be 0. Okay. I hope you are following. I hope you are following. So occupation is 0. So you write 0 here. You are told that the people are in a fishing village. So it means that even if you go and write the other one, by the way, if you check it, you see the value of the other one is negative 46.47. So negative 46.47. That one is occupation trading. But you have been told that the people are in a fishing So it means that trading is what value? 0. Okay. You have been told that the people are Christians. The people are Christians. So when we come to the next one, which is dummy for Christian, okay, that is 15.55. Okay, so that one is plus, so it'd be plus 15.55. And because the people are in a Christian, the value here will be what? 1. Okay, it will be 1. And then religion Muslim will be what? 0. I will not even write that. Religion Muslim will be 0 because the people are Christians. That understanding is all. Once you got this, all you have to do is to find the answer. So those that are 0, cancel them. Those that are 0, cancel them. Cancel them. Cancel them. And then you take your calculator and then you calculate the right answer. Who was following me and can tell us the answer? Who was following and can raise a hand and tell me the answer? Because somebody is following, someone is not following. And you'll be sure who is following. Okay. Because that would be fantastic. Yes, Alina, tell them the answer.
253.92.
Good. 253.92. That is the answer, okay, that you will get. So that becomes the predicted quantity demanded. Forget about the decimals. This is just for calculative purpose. We can always round it. Okay. That is how you execute this very plans. Yes, Gazari.
Doc, thank you. Doc, please, the figure close to the 15.55, which is 1. Please, can you come again with the explanation for me, please?
Okay, so the question was asking that we were told that the people are in a Christian population. And this 15.55 is for religion. Check your book. If you have written what I have written, if you are following me in total, normally, sometimes students don't follow. When I'm writing and I tell them they should write, they don't write, they don't follow. Okay? But if you were following, you will notice that 15.55 is Christian. Now, we have been told that the people are Christian population. So if they are Christian population, religion Christian will be 1. Religion Muslim will be 0 because they are not Muslim population. If they were Buddhist population, then religion Christian will be 0 and religion Muslim will also be 0. That is how it works. So every dummy that is in the story, any other 10 that is not that dummy must be 0. And any other 10 that is that dummy must be 1. Okay. So that is how you actually eliminate 0 and 1, 0 and 1 for the dummies. For the numbers, they are actually given to you, so you know exactly which number. So I hope, Gazari, you get a picture. Okay. Now, that is the part of that question. But you can also get this very one, because this is the one I'm about to show you. That's the one that will come. Okay, so that's the one that you want to understand. I can ask you that, okay, this time I want you to look at 2 scenarios. Okay, let's look at 2 scenarios. I can say that. Let's look at 2 scenarios. In the first scenario, the people are this, that, scenario 1. In the second scenario, the people are rather this, that, okay, scenario 2. And then I'll tell you that in both cases, I want you to calculate the quantity demanded of scenario 1 and calculate the quantity demanded of scenario 2. And then tell me the difference. So let's say that you do the calculation, the quantity demanded for scenario 1, we got 405. And then the quantity demanded of scenario 2, we got 300. Then it means that the difference is going to be 105 in favor of scenario 1. So that will mean that scenario 1, the quantity demanded will be more by 105 than scenario 2. Now let's take a typical example of that kind of scenario, because I'll not ask you individual, I'll ask you scenarios. Then you can now compare and then check. Let's quickly go and look at this scenario. So look at what is on the screen now. What does it say? It says that compare. Compare means that there are 2 things you're looking at. Compare, okay, the predicted quantity demanded. So now we are looking for 2 quantity demanded, but then there are 2, so you have to compare them. Now look at the scenario now. We have been told that in the first case, it's gin bitters that was made by some Muslim traders in an urban town. So watch the keywords: Muslim traders in an urban town. Then compare that with that of the quantity demanded of gin bitters. This time it was made by some Buddhist fishers in a rural area. So you can see that there are 2 different scenarios: Muslim traders in an urban town, Buddhist fishers in a rural area. But you were told that when it comes to the numerical variables, you were told that given that both, that word is important, both of them cost 5 cedis, both of them have a complement price of 15, and both of them have the average real income of the customers to be 20. So this scenario is telling you that the price is the same for all of them. The complement price is the same for all of them. The income is the same for all of them. The only difference in this very example, please note that it's not all the time the numbers are the same. It's not all the time that the numerical variables are the same for all of them. Could have been that the price would have been 20 for the Muslim traders in an urban town, and the price could have been 58 for the Buddhist fishers in a rural area. It could have been different. But in this very example, they are all having the same price, the same complement price, the same income. How do you deal with it? So the first thing is to generate your capacity for the first scenario. Okay. So I want you to take note of the scenario and then go through. So the first one says this. It says, let me just go back. So if I were to write, okay, normally I don't like to write, but if I were to write, okay, so watch. So I'll write quantity demanded, and then you have to bring your 280.25. If you can remember the first lecture on this, I told you that the constant has no meaningful interpretation except during prediction. That is why you can see that the constant value, the intercept value, we are always bringing it. We are always bringing it. This time, we are always bringing it because it's beautiful when it comes to prediction. Okay. Now, the next one is minus 3.15, if you can remember your equation. So you can see that your equation is very important. You're supposed to get your equation correct. Your estimated equation, you're supposed to be correct. Because if it's not correct, all your predictions are going to be wrong. All right, okay. So it is negative 3.15 price. And in the first, now I'm doing scenario 1. So let me just put Q1. The price is what here? Well, you can see that the price is 15. The complement price is 15. Then the income is 20. So price will be 15 here. Okay. The complement price, if you can remember, it is negative 0.11 complement price. And that one is also 15. And then we are told that minus 0.98, that is a coefficient for income. And income was told is 20 for all the scenario. So that one is sorted. What is now left? We are told that the people are Muslim traders in an urban town. Okay, all right. So how do we go about that? Muslim traders in an urban town. To do that, you have to now go to the location, because that's the next one, the location. Now, if you check the coefficient of location, you will notice that the coefficient is minus 0.511. Minus 0.511. So you can put that one somewhere down here. Minus 0.511 into bracket location urban. We are told that the first group, are they urban people or they are, what will be the value? Is it 0 or 1? Type it for me. Is the value going to be 0 or 1? 0 or 1. It's 1. Very good. You guys are following. Then we are told that the occupation teaching. Okay. So occupation teaching is 19.42. 19.42. So you do minus 19.42. 0.42, occupation teaching. Is it 0 or 1? Let me write occupation trading. Occupation teaching, is it 0 or 1? And now you guys should be cracking the code very well. Let me see the answers. It is 0, very good. It's 0. Okay. So you put 0 there. Okay. Occupation trading, is it 0 or 1? Occupation trading. Is it 0 or 1? Please note that this one is 46.4. So occupation trading, it is 1. Very good. Because the people are traders. Okay. So that is 1. Then you go to religion, Christian. Okay. So remember, the value was 15.55. Okay. Religion, Christian, is it 0 or 1? For this very first scenario. Religion. For me, I'm interested in your substitution. Very good, 0. Okay. And then religion, Muslim, okay, minus 23.01. Religion, Muslim, is it 0 or 1? If you can substitute, the rest you can do is 1. Very good, it's 1. Very good. So if you do the substitution correct, like we have done, and you go and do all of this calculation, ladies and gentlemen, you will be in a comfortable lead. Let me show you the answer that you're going to get. If you do it well, you'll be in a comfortable lead. And this is going to be the answer. You're going to get approximately 136.79 for the first scenario. For the first scenario. If you take your time and check slightly, you'll get something like this. Okay. Now, the second scenario. The second scenario. The second scenario, nothing changes. I'm just going to go through that. Nothing changes. We are told that the price is the same thing. Okay. Remember the price, the complement price, the income, they are still going to be 15, 15, 20. Okay. Now, in this second scenario, LU, location urban, let me just make it quick. The location urban will be what? Will be 0 or 1. Remember, these people are Buddhist fishes in rural area. Buddhist fishes in rural. So location urban, will it be 0 or 1? Very good, it will be 0. Occupation teaching, 0 or 1? Occupation teaching, it will be 0. Now, let me just, occupation teaching will be 0. Very good. Occupation trading will be what? 0. Yeah, very good, very good. What about religion Christian? Religion Christian, remember the people are Buddhist fishes. Religion Christian will be 0. What about religion Muslim? That one too will be 0. Okay. So if you check it carefully, they're going to be 0. So you can see that they are all, if you check here. Okay, they are 0, they are 0, they are 0, they are 0, they are 0. So the only thing that is working is a PCM. The PCM. So you have to calculate those that are not 0, because the 0 should go away. If you do that carefully and you respectfully punch your calculator, you're going to get a beautiful final result, which is 211.62. 211.62. So the second scenario is 211.62. The first scenario is like 136 point something. So now the difference is that which scenario is going to be a better quantity demanded? Which scenario will be better? Scenario 1 or 2? Which scenario will give us a better situation? And in this case, you have to find the difference. It's 2. So you have to calculate the difference. So watch this. When you go and look at this, I can see that I've documented that in this situation, scenario 2 is better than scenario 1. Why is it better? Scenario 2 is better because the value, the difference in the values, scenario 2 gives us more. Okay. And every time the question will ask you which factors are driving the difference. In fact, when you go back here, you will know the factors that were really driving the difference. Look at it. We talked about Muslim traders. watch the word, Muslim traders in an urban town. So by mentioning Muslim, that means religion is causing a difference. Traders, it means occupation is causing a difference. Urban, it means that location is causing a difference. Because when it comes to the other one, it changed. It changed. That one was what? Buddhist fishers in the rural town. So the factors that are causing the difference, the comparative differences, are the following. Sorry, these are the factors. Okay. Every time you will ask, okay, in this very example, one of the things you should notice is that the numerical variables were the same for both scenarios. And so there is no much difference when it comes to the numerical variables. But if it was a different situation, you will notice that some of the numerical variables can cause differences. But in this very case, most of the differences was driven by purely the dummy variables. The dummy variables. Okay. Ladies and gentlemen, that is how you attack this sort of regression. There's one more to look at. Okay, and I want to quickly take you back there because I don't want us to forget this. There's only one more thing, and that is variance inflation factor. Variance inflation factor. If you are taking notes, you want to take note of that. Variance inflation factor. I just want to recapitulate some few things that we know. Just look on the slide. Do you remember we looked at multicollinearity? Do you remember multicollinear variables? Okay. Sometimes you might think that you never meet some of these words again. Then you come and meet them again. Then they start looking at you. They are ugly hairs looking at you. Okay. Multicollinear is ugly looking at you again. Multicollinear variables are independent variables that are so highly correlated that it becomes difficult to disentangle the partial effect of one from the other on the dependent variable. So multicollinear variables are independent variables. Now, who can tell me all the 3 pairs of multicollinear variables we selected the last time? All the 3 pairs. All the 3 pairs of multicollinear variables. Who can tell me all the 3 pairs of multicollinear variables? Okay, Michael, tell us all the 3 pairs.
Okay, so we selected price and the complement.
Are you looking on your notes or you are just mentioning?
Yes, price and complement.
And what was the value?
The value is minus 0.74.
Okay, stop there.
No.
It's okay.
It's
okay. You see, I knew that you are not looking on your note. Okay, it will be best you are looking on your note so that we move slightly, not with guesses. Adam, let's go.
Yeah, P and OTR.
P and OTR, that was the first one.
0.76.
Good, that was this.
Then P and C.
P and C.
Into bracket minus 0.74. And then the third one, M and RM at minus 0.73.
Good. So these were the variables that we selected. Now, the thing is about, in real life, what I'm about to tell you doesn't always apply in real life. Multicollinear, we said that it is not that much a good news, if you can remember. So when 2 variables are highly correlated with each other like this, the final result is what I'm going for now. But in real life, you have to do other things before the final result. So the final result is to delete one of them. So it's like we are now in a twist of a battle between deleting P or deleting OTR. Which one should we delete? Deleting P or deleting P's complement price? Which one should we delete? Deleting M or deleting RM? Which one do we delete? Okay. Now, like I said, I'm using the extreme situation. But the one to delete will depend on something known as variance inflation factor, VIF. Variance inflation factor, VIF. the variance inflation factor. That one will tell you by how much the variation is inflated, okay, in the regression equation. And as a result of that, the variable that is causing much of the variation, okay, and the inflation is the variable that has to go. That has to be deleted, or that may be deleted from the regression model. Now, some authors have suggested, like here in Blackett, some authors have suggested that if the VIF in real life, if the VIF is greater than 10, then that variable is a concern. Then that variable whose VIF is more than 10, that variable is a problem variable. Now for this course, I'm going to give you some little rule for this. If two variables are multicollinear, I'm saying that the variable that is having a higher VIF should go. That's a key point I want to take. Variable with higher VIF. Okay. The variable with the higher VIF. I say higher because I'm comparing. Okay. With a higher VIF is the one that must go. Higher VIF. So what we have to do is that we have to look at the VIF, the variance inflation factor, between P and OTR, between P and C, between M and RM. When we look at the VIF of them, we will now be able to determine which one may be deleted. Now, I will always calculate the VIF and give it to you. So for each independent variable, I will calculate their respective VIF and give it to you. And I'll show you how I got the VIF in that regard. So I'm not gonna bore you much in computing this, but I just want to let you know that I'll do that for you. But for now, I'm just going to show you the, what do you call it? The VIF of these variables. But of course, in your assignment, you have to learn how to calculate. Now, normally I'll bring the VIF after the p-values. After the p-values, I'll give you one column for the VIF. Okay, then you can look at it. After the p-values, I'll usually give you one column of the VIF, then you can check it. So how do you see the VIF? How do you get the VIF? Where do you see the VIF? Now, I'm just quickly going to show you a table where I have calculated the VIF. Then you can check. So look here. Okay. So if you look at this last column here, okay, the same things, just that I've done a different, I've calculated the VIF of each variable. So for example, this is price. Okay. This is price. That's the first one. That's price. So that is a price, the VIF of price. And this is OTR. This is OTR. This is OTR. Okay. Okay, that's OTR. So guys, what I want you to do is that the first variable that was multicollinear was price and OTR. Looking at their respective VIF, which variable may be deleted now? Which variable must go? Which one must go? Which one must go? Like I said, I will normally calculate the VIF and give it to you, but then in the assignment, you have to do it yourself, and I've shown you that. Yeah, which variable must go? Who can tell me? P, exactly, exactly. Now, between P and C, which variable must go? Between P and C, which variable must go? Excellent. Once again, it's P. Okay. Between M and RM, which variable must go? Between M and RM, which variable may be deleted from the regression? That's the last result. Okay. So most of you, all of you have gotten, okay, it's RM. It's RM. And you will always write the reason why you said that. Because it has a higher VIF of, then you now mention the number. Okay. That is how you execute that last question. That is how you execute that last question. Dennis, are you there? Excellent. Very good. So